Hello and welcome. In this tutorial, we will learn how to design primers, and towards the later part of the video, we will also learn how to do a quality control analysis of these primers. To design primers, let's head to the NCBI website as shown in the screen below. In this web page, click on Blast and then scroll down to Primer Blast. This step redirects to another web page. NCBI prefers the following format like accession number, GI, or a FASTA to be used as an mRNA template to design primers. For this tutorial, we will use the FASTA sequence of a mouse GAPDH mRNA. To do this, head to the NCBI website, select nucleotide from the drop-down, and in the search bar, type in GAPDH. And since we intend to use mouse species, let's type in Mus musculus and hit the search button. This redirects to another site that shows GAPDH mRNA sequences. It's indeed important to select the sequence of your interest. For this tutorial, let's select the complete CDS sequence since we are interested in the FASTA format. So let's go ahead and click on FASTA and then copy the entire mRNA sequence. Since the requirement is a FASTA format, so let's type in the greater than symbol and name it as GAPDH. And then in the next line, paste the copied sequence. It's really important to set the primer parameters that suits your experimental condition. For instance, you may have an intended PCR amplicon size. To design a real-time PCR primer, probably you may require a primer pair that amplifies with a smaller amplicon size. This software can return with as many number of primer pairs of your choice. Let's keep it as 10 primer pairs for now. The primer melting temperature can be adjusted as well. For the GAPDH primer, let's keep an optimum of 60 degrees Celsius, and one could set the minimum and maximum accordingly. The other options like exon junction span can be adjusted according to your template sequence of interest, and similarly the exon junction match. Unless the PCR template is a genomic DNA or includes introns, these options can be left as default. Primer specificity parameters are very crucial to design a good primer. To perform the specificity, select the specificity check and leave the search mode to automatic. The database is RefSec mRNA by default, or select genome for selected organisms if the PCR template you chose contains introns. Certain mRNA transcript variants can also be excluded using the exclusion parameter. It is very important to select the correct organism. In our example, we selected mouse GAPDH mRNA. Therefore, the organism here needs to be changed to Mus musculus. Default parameters can be used for the primer specificity stringency unless you wish to change. The maximum target amplicon size can be set according to your choice. The last parameter provides you with an option to include or exclude any splice variants. Once all the parameters are set, click Get Primers. This step redirects to another web page that shows the date and the time of the query submission. It can take a while, or you can click on Check to refresh the page. The mRNA template that we used did match with variant 1 and 2 of the GAPDH mRNA. You can select the sequence of your interest and then click Submit. This process might again take some time depending on the server or the internet speed. Now, this web page displays a list of 10 primer pairs designed by the Primer Blast software. The graphical view of the primer pairs basically shows the location of the primer pairs along the template mRNA. It's totally up to you which primer pair to select based on the location of your interest. Let's go ahead and check the primer pairs. Primer pair 1, primer pair 2, 3, and so on and so forth up to primer pair 10. Let's analyze the primer pair 7 in detail. It consists of a forward and a reverse primer in 5' to 3' direction with an amplicon size of 85 base pairs. It also displays to which template strand the primer should bind to, whether plus or the minus strand of the gap DH template. The length of both the primers are 20 base pairs in size. A good primer can have a length between 18 to 30 bases, and the shorter the primers, the better it is, as these primers would more efficiently bind or anneal to the target DNA. It also displays the start and the stop side of the primers in the gap DH template. The melting temperature of both the primers are close to 60 degrees Celsius. In terms of the GC content, good primers generally have between 40 to 60%, which is pretty great, I must say, in these primers. Also, the self-complementary of both the primers are alright and acceptable. Let's head to the primer pair 2 and check its features. Well, all the features except the sequence itself and the template binding location are similar to primer pair 7. However, in my opinion, I would choose primer pair 7 over 2. The reason being, the forward primer here ends with the nucleotide thymine, and thymine would pair with adenine of the template DNA during the PCR reaction using 2 hydrogen bonds. On the other hand, in primer pair 7, the forward primer starts and ends with a guanine nucleotide, which would form a triple bond with cytosine of the template DNA. Therefore, this primer would bind stronger to the template DNA during the PCR reaction as compared to the primer pair 2. Now that we selected primer pair 7, let's check their quality control. To check the qualities of the primers, download the Generunner software into your computer from the website. Next, install and launch the software. Click on Analysis, then Oligos, and paste the forward primer sequence into it. You can go through these specifications if you want to. What is needed to be checked here is to analyze whether this primer has any hairpin loops. And yes, this forward primer does form 2 hairpin loops. However, it does only form when the temperature reaches 6.8 and 44.7 degrees Celsius, which I believe is not achieved during the thermal cycle. Next, check on the dimers. Yep, there are 5 dimers that could form. However, the possibility is null since none of these temperatures would be achieved during the thermal cycle. Let's also check the bulge loops, internal loop formations, and the match sides, and this seems to me alright. Similarly, the reverse primer can also be analyzed for quality control using this software. To avoid secondary structures in the primers, the sequence must have a balanced distribution of GC-rich and AT-rich domains. Thus, selecting primer pair 7 seemed to be quite reasonable as seen from the sequence and the quality control itself. Thank you for watching the video. If you like the tutorial, go ahead and hit the thumbs up button. Also, do stay tuned for more videos like this by subscribing to my channel.